I'm back with another kind of little bit more complex example, but still probably shorter than the actual data and queries that I would be writing for my database. But anyways, here is a data structure to kind of a mock data structure, and then also we have a couple elements that are kind of describing this image on the right, which is why I pulled that up. Plus, it's my latest commission, and I think it's cute, so I want to look at it. But anyway, so we have this construction here, which is an image. It has some metadata, including what looks like a file path, the artist name, and then just like some kind of comment or something. The name of the outfit that she's wearing, and then kind of a brief description of it. And then what we want to do is we want to, from this data structure, we want to first of all match the data structure. And then we want to pull the file name and the artist name out of it. And the reason that we're matching on this is not, I guess I realize now is maybe not entirely clear, but the idea of this query language is that when you match on a structure and it doesn't match successfully, then it will be filtered from your query, right? So it becomes a predicate that you can filter a set of results from. But we don't have a set of results; we just have the one. So if we fail to match on this value in our query, then this will just return nothing. But in the future, when we're actually running queries over like some domain of images, when we're actually running queries over a series of values, then matching will be more apparent as a way to filter results from the query. But that won't be ready for some time. But I'll probably, I don't know. I guess I will make another video about that. But who cares? Anyways. Here's a little description, right? So first of all, what we do is we construct this value, and then we compose it with this pattern match right here, which first of all matches this image constructor. And then what we do is every argument in the image constructor is bound to a variable. So the variables are lowercase, and then when they appear on the left-hand side of one of these match arrows, it becomes a binding, right? So in this construction, we're binding this metadata construction to this MD. This costume gets bound to costume name, and this value gets bound to this outfit description. So we're binding all these values, and then from this pattern match, we are projecting this outfit description value, and we're composing that again with another pattern match. So here, projecting outfit, and then matching on this outfit that we projected after composition. And we're asserting that this outfit, first of all, is in fact an outfit, and then second of all, that its second argument is a colored sweater, and then this matches anything, because I don't actually care what color the sweater is. I just want to make sure that there is a sweater here. And then the rest of these are wildcards because I don't care about those either. And so this doesn't have an arrow because this little clause here is optional. This just states like what you want to project from a match, but you can just write a match just like a guard, and this will by default project whatever value is in scope. So this here is the exact same as this. It's just a little bit shorthand and it saves some writing. So anyways, yeah, this is a guard. And then from here what we're doing is since we are outputting this outfit description here, we've already done our matching on this. I just want to replace this value with this value that's bound to MD. So I just call MD, which calls this reference, which looks in the runtime and finds this value here and replaces that. And then I compose that with this pattern match here. On metadata, I bind this string to the file path variable. I pattern match on this artist construction so that I can bind the string to this artist name variable. And then here I'm binding this comment to a variable which I'm not using, so I'll just replace that because I don't care about that. And then if I run this file here, I should see that I get the file path and the artist name here. So I do that, and then here's my result. and it has the file path and it has the artist name in it just like that, right? So now I'll show you an example here of what happens if the value that we're matching on is different from our query, right? So say here in this match I'm expecting a colored sweater, but what if instead of a colored sweater she's wearing a colored dress? We run that and it got rejected because this pattern does not match, right? And so if I was running a query over values, then this value would get thrown out and then the rest of my values would be matched, you know, some other time. But this counts as a rejection because it doesn't match. So that's where the querying part comes in, right? This is like kind of a where clause sort of deal, you know. So let me replace that. But then what if I have kind of a weird tag structure where I have these outfits declared, but I also want to make sure that this outfit basically corresponds with this costume, right? Because it does. She's wearing her lollipop outfit, lollipop honey outfit, which is a pink sweater and a blouse and a necklace and stuff like that. So they should be basically the same. So what I can do in my query is I can just add here below this outfit pattern is just add a wildcard that matches anything, and then have kind of a little subquery here, and I will project this costume name and then compose that with a pattern lollipop honey. So what this is doing is and let me also from here, let me do this. Well, I'm trying to think, how's this work? I probably want to project this, right? Because these are both projecting that value. Anyways, so what this query is doing is saying match an outfit with a colored sweater, and if that doesn't match, then test that the costume name is equal to lollipop honey. So if I run this example, then we do get our result, but that's because it matches on this colored sweater. So if I change this to a dress and I run this again, we still get our result, and that's because it matches here on this lollipop honey. So then what if I change this to a different outfit name and run that? Then it gets rejected because neither of these cases are matched. So hopefully that's an example that kind of makes sense about how you can compose matches to form guards over the value and then also project data from them. And then also how when you match, you can use data that you've bound in previous matches to construct new data, which will be very useful because if you ever change the schema of your database, this will be the mechanism that you use to migrate your data, right? Because you have your old data definition. The only thing that you then need to do is just write a morphism from your old data to your new data, and then your migration's complete, right? And that's it. Which makes migrating very easy, I believe, in theory, probably, right? Anyways, I think that's what I got for now. So feel free to let me know if you're watching this video and you think that this syntax is horrible. Let me know. This little arrow operator, by the way, there's a precedent for that in Haskell as part of an arrow, which is a superclass of a category. It's a more general form of computation than a monad, but this arrow is literally just forward composition. So, right, I think I said before, I can't remember if it was in this video, but like the dot operator in Haskell is function composition. So like this is like saying g of f of x is the same as saying g f x, like that. And then this little right arrow operator is the opposite of that. So this becomes f right arrow g of x, then becomes is that same thing. It's just flipped, right? So anyways, in case you're confused about this arrow showing up when it seems like some of this other syntax is lifted straight from Haskell, this operator is too, just by the way. So yep, that's what I got. See ya.